Hi, welcome back to deep learning tutorial. Today I'm going to see about the transfer learning with fine tuning. I'm going to see the implementation. That is, the previous session I explained what is transfer learning. When you doubt, please kindly check the playlist. Transfer learning is nothing. What we can say is a powerful technique in deep learning, or you can say one of the technique in machine learning where we can use the pre predefined model to solve the new problem. So if your data set or custom data set, what I'm there, you can go for train. After pre-training, everything completed, you can approach everything and go for fine tuning. So once go for fine tuning, we'll get many benefits, and also it's optional for you. So let's start the session. So this is a tutorial where you can say where you can say the project classification of image class dog or cat. So once you go through for implementation, what will happen? We can find out, predict, and say whether it's a given input as a cat or dog. If at all cat means it's a cat, if at all dog means it is a dog, or else it can predict and display whatever the data is there in the one. So here first starting, I'm going to time to avoid the time delay I already executed. So first of all, I'm going to import the packages like Matplotlib, NumPy, OS, and TensorFlow. So TensorFlow, as of you know, is one of the open source library for machine learning. That means it's using the machine learning for anything. So if you want to go beyond the custom data set access and do anything, you can go with the help of TensorFlow. Keras also there. So here I'm going to check the URL like this, online URL. Then I'm going to copy that clone, that is cats underscore docs.zip. Then I'm going to set the path and train directory where I'm giving the train and validation and batch size. I'm just saying as 32 and followed by image size as a 160, 160. So this is the input image. I am going to set as a 160, 160. Then I'm going to call train data set where I'm giving you the information. What is the information? Then when I give execute, what happen is download the data from that Google appis.com for cats and dogs. So there will be around more than 10,000 images there. It may vary and remain. Once you execute the code, what happen? Once you execute implement the code, it may vary and give the different results. So once given, it will say found 2000 files belong to the two classes. Then I'm going to use the validation data set where I'm going to call the tftar carousel details dot image underscore data set from directory where I'm going to give the information. Once give it to say found 1000 files belonging to two classes. That is one is cat, another one is called dog. Then we can go for a visualization. So visualization we can use some class names where you can give train data set dot class names. Then plot figure, I'm giving the plot axis of or class. Once given means what happened, you create it and they keep the name like dog means dogs, cat means cat. Like here it lists out some of the dogs as well as cat also. So with labeled name, predicted and saying labeled name like. Then you can go validation batches, then go print the number of validation patterns. How long here? It will say approximately 26 and followed by test batches 6. So as of now, generally when you go for training and testing, training 80% of the image you take and testing will take 20% like that only. So then I'm giving auto tune, I'm giving where I'm giving the train data set everything. By default, the data augmentation. So in scope data augmentation, we can change the image. That means the input image maybe horizontal means horizontal, or vertical means vertical, or rotate. Whatever one you can do here, I just keeping the horizontal. Horizontal means you are just showing the image. If you make vertical, it may change, resize the image also later. So then I'm going to give the for image the in train set. What happened? I'm going to do the size as 10, 10. You can go to use the plot.im show where augmented image that is by 255. So once given like this, what happened? The figure size may be 10, 10 and the horizontal only. So let's see the horizontal and showing the images at present whatever there in the visualize the image. Then you go for pre-pass input, then follow the rescale where I can give the rescale of 1 point by 127.5. This is if you want you can go rescale the image, that means change the size. Then I'm going to create the base model from the pre-timed model from MobileNet V2. So I'm going to get the help of one of the CNN model called MobileNet V2. Later we discuss everything. Then I'm going to give the image size. After giving the base model everything, we get the information like downloading the data from the above link only. Then I'm going to give image batch size where label size is giving as some number. Then base model. Then I'm going to create the
base model architecture. So if you want to create the base model architecture, what you can do, the transfer line you can give base underscore model dot summary. Then you have to wait for some time. It will generate the model based on the net speed and Google Colab anything. Then it will say the total parameter and so on. Then I'm going to give the global average layer where I'm going to set tf dot keras dot layers and so on. Then it will print at last 32 comma 120 1280. So remember here future extraction is the one of the important consideration when you go for transfer learning also. Then it is a prediction layer where we predict and say the answer like 32 comma 1, and inputs we are giving us a shape of 160 comma 160 comma 3 where just now I told you. Then I'm applying the data augmentation, pre-pass data, then base model, global average, everything for training the data only, training the data set. Then I'm going to give model dot summary. It will give the information like input sequence and so on. Then print the details. Then length. Here the length is 2 only. Then I'm going to give tf dot keras dot util dot plot model where we show the generation architecture for understanding about the transfer learning. So what I given, it will take some time, and with the help of mobile net v2 version. Then after that, we go for base learning where I give the number called 0.0001 and model dot compilation. After compilation, as usual, now initial underscore epoch is called 10. Then I'm going to give some information. Then you to print the answer. Then print the initial loss and the initial accuracy. Here, initial loss is by default 0.83 and accuracy is 0.41. Remember, once again, if you execute, the data will be, the output may vary based on your data set and also everything. So history model I'm developing. After developing, take long, say this step take a long time, and I'm going to give set the accuracy where I'm going to plot figure. It display the information of training and validation accuracy for your custom data set. I'm saying about image classification about the dog versus cat. So it will print the information like this, very simple and easy. Then I'm going to give base model, trainable is true because we are going to train and fine tune also necessary. Then I'm going to give number of layers in the base model and fine tune at equal to 100 where it gives the information of number of layers in the base model is 154. So we are connecting with a mobile v2 version. Then I'm going to model.compile, then model.summary. Once you execute step by step, you will get a clear answer clearly. Then length is 56 like that. Then fine tune Apache I'm giving a size as 10. Then I'm going to give execute it. Then after execution, go for accuracy. Then plot figure where it display the information of train accuracy, validation accuracy in the graph mode. So it's showing like this. This is the graph showing the training validation, and start fine tuning also. So with the help of fine tuning, we'll get more good results. Where give the start fine tuning, training, and go for a loss accuracy, print the loss accuracy, whatever there. Then retrieve a batch of images from the test set. That means if you have 10 images, you can test at least 4 or at least 2, like that. Then apply sigmoid since your model. After predictions, it will display information at last like the prediction of one after applying the mathematical function called something like sigmoid since. After we will get the information and display the image like dog, cat, again cat, dogs, almost predicting exactly what are the input given here. So this is the way how we can work with transfer learning with fine tuning for classification of given input, whether it's a or inputs as a class, sorry, cat or dog. If you like the video, please subscribe and share with your friends. Thank you for watching the video. Thank you.